Hello and welcome to this Haas Tip of the Day. Now we know what this is. It's an ER collet, and it seems like half of the rotating tools that we use in our mills and our live tooling lathes are being held in one of these collets. That makes these a critical part of our manufacturing process and something worth understanding. Now there are lots of moving parts in our ER collet holders, and each one of those pieces can either make our tools cut better or worse, so stick around. This is an ER collet tool holder, the most used tooling system known to man. Now they've seen constant improvements since they were first introduced by Rigofix in 1972. They've since become a DIN standard. Now I think they're so popular because one size holder can hold an entire range of tools just by exchanging the collets. Other types of holders, like shrink fit holders, can only hold one particular size of tool, meaning that you need a whole bunch of different holders. That can get expensive. When we set up a tool in an ER holder, we're looking for two things. Number one, we want to maximize the clamping force transferred to that tool by the collet and the collet nut. And number two, we're looking for the minimum amount of runout, or TIR. When I say TIR, I mean total indicator reading. This is a complete range of runout or wobble measured at a given point on your tool. Now we can measure this in the machine with an mag base and an indicator, or on an offline tool presetter. A strong tool clamping force dampens vibration, allowing us to run at higher RPMs, and it lessens chatter. And a tool that's running true with very little runout will wear more evenly, lasting longer and giving us better part surface finishes, with all of the flutes doing the same amount of work. Wobbly tools can also cut oversize, which can put us out of tolerance and force us to scrap out our parts. So we've got some really good reasons to set up our ER tools properly. ER collet systems come in different sizes and different levels of precision, but in a nutshell, there are 8 different sizes of collets, there are 4 different styles of the collets themselves, and 4 different styles of collet nuts. And it doesn't take forever to learn this stuff. We're going to start with our collet holders. ER holders come in different sizes based on the collets they can hold, ranging from ER8 all the way up to ER50. Now this is driving some of you crazy. I'm only showing you 7 different collets here. Well, that's because I don't have an ER50 collet on hand. I'm not going to buy one just for the video because I don't use them every day. Here, better? Our ER numbers can be found just by measuring the holder cavity. If we measure 16 millimeters in diameter, then we've got an ER16 holder. 32 millimeters, we've got an ER32. We can also measure the outside of our collets as well. We'll choose our ER holder based on our tool's shank diameter and the reach and clearance that that tool might need. A tool in this holder is going to cut better and faster than a tool in this holder. The only time I'd want to use this instead of this is if I need the reach or the clearance. Now, sometimes we don't have a choice in the matter. Sometimes we've got to get creative because our part or our fixturing demand it. Now, here's a chart for you showing the maximum tool sizes, that's shank diameter, that can fit in any ER holder class. Now, lots of tooling vendors make collets that are just slightly larger than the numbers we've shown you, but these are great generic values. Once we've decided on our tool and an ER holder class, it's time to choose our collet and our collet nut. Now this is really important. Our decision here is going to have a big impact on how those tools run. Here we've got 4 different styles of ER collets for you, each with its own special use. Right away you can see a difference between these 4 collets. We've got our 16 slot standard collets with a 1 millimeter collapse range. We've got our 12 or 16 slot high performance collets. Many of these collets come with colored bands on them to set them apart from their standard collet brothers. We've got our tapping collets. Those have 8 slots, 4 on the top and 4 on the bottom. And you can also see a square receiver in the bottom of it, which will match up to our taps to keep them from spinning. Then we've got our sealed collets. These channel the coolant through our through-spindle coolant tools. We can use a standard 16 slot collet for just about anything, from drills to reams to end mills. Now, one of these standard collets is good for about 10 microns of TIR, or about 4/10 of a thousandth of an inch. Most are better than that though. We'll use our high performance collets for detailed features or performance tools, or just when we want to extend the tool life of a tool for production. But then again, when do we not want longer tool life? Okay, these high performance collets might have 5 micron of runout, or 2/10 of a thousandth of an inch, with some, like this Parlec EROS system, built to hold just 2 microns. That's 1/10 of a thousandth of an inch of TIR. That puts this holder on par with most hydraulic and shrink fit holders, but with the adaptability of an ER collet system. Now, there are a lot of different brands of high-end collets and collet holding systems out there, so check around. Here's my 12mm end mill, and from the chart that we showed you earlier, we know that it could fit into an ER20 holder, but we've decided to go with the much larger ER32 holder for a better hold. Now let's take a field trip and grab that collet. So this is one of our mini bending machines here at the factory, and I can look at my chart here and I can see that my ER32 collet for a 12mm end mill is in slot number 36. So I can just issue that out. And you can see right here on the end of our box, it says 12 for my 12mm end mill. But is this a plus or minus number? Can we go bigger than that with my tool, smaller? How does this work? If we open up the collet and we read it, you can see that this collet is good for a tool that's between 12 and 11 millimeters in diameter. It's written right on the collet. Now, looking at our chart, it looks like all of these collets are good for a 1 millimeter range. Here's how these collets work. They are meant to collapse, not to expand. If you find a collet that says 12 on it, it's not good for anything bigger than 12 millimeters. It's good for 12 to 11, even if it doesn't say it. Well, let's go back to the bench. Now we want to use, it was really loud over there, it's much quieter over here. We're going to use the tightest collet available for the tool that we're going to use. This is going to give us the most tool to collet contact area and the best run out. Now we're using a 12mm tool, so we're going to use the 12 to 11 collet and not the 13-12 collet. Now, a lot of high precision collets are actually on size collets. They're meant to be used with a certain size tool. Some collets, high precision or not, might only have a 1/2 millimeter collapse range. So always look at the collet, make sure you read the number, and you understand how that works. But what if my tool is just 10/1000ths of an inch bigger than my collet? I can still make it fit, right? No, you can ruin your collet. Now we have our tool, our holder, our collet. Now we need our collet nut. And these nuts come in 4 basic flavors. We've got our flush nut, our low friction nuts, our coolant nuts, and our mini nuts. Now there are lots of different types beyond this, but these are the basics. Flush nuts are the least expensive, but they're strong and they're great for general use. They're called flush nuts because the collet comes flush with the face of the nut, which is great if you don't want to have to stick out your tool any further than necessary. Low friction nuts make use of bearings, bushings, or special coatings to reduce friction on that 30-degree surface where the top of the nut makes contact with our collet. Now, this helps us to give more transferable torque right to the tool. This makes a difference. We can actually get 50 to 100% more tool holding force directed right onto our tool. This makes a big difference when machining. If you have a ball nose tool in an ER collet, and I had my choice between a standard flush nut or one of these friction bearing nuts, I am definitely going with this nut. Every manufacturer has their own version of them. This is a Parlec power nut. You've got the Rigo Fix ERBs, you've got the Lindex bearing nuts. So check with your manufacturer. You definitely want to know the difference between this nut and this nut. They also require different torque values. And behind door number 3 are our coolant nuts, which make use of these coolant discs, making them ideal for through spindle coolant tools. Now these coolant discs, or sealing discs, come in 0.5 millimeter ranges to perfectly seal for every tool size. When we load up these discs, they just snap in from the underside of the collet. Now when we load our tools, we want to load those from the top side of the collet. If we load them from the bottom up, they could damage the O-ring on our disc. Now, low friction nuts have better tool holding power than a coolant nut or even a flush nut. So what if I want to run TSC through spindle coolant, but I want all the tool holding power of the power nut? You can do this without a coolant disc if you use one of those fancy sealed collets that we showed you earlier. In fact, there are collets out there like this Jet 2 from ISCAR that can turn any tool into a TSC tool, kind of. The collet is sealed, but special grooves have been added to direct the coolant right at the tip of the tool. Now you can run TSC through a standard collet as well, and it'll help out quite a bit. These specially designed collet nuts and collets are just better at getting the coolant right where it needs to be. Finally, we've got our mini nuts. Now these function in much the same way as a typical flush nut, but they have a smaller diameter. All of these collet nuts here are for an ER16, but you can see that our typical hex ER16 nut is just under 28 millimeters, a good nut. These mini nuts are under 22 millimeters for an ER16, so I can reach into spaces that I couldn't otherwise. That makes these type of extensions with mini nuts ideal for my live tool tooling. With all of our components ready, it's time for us to assemble everything. We need to keep our collets clean and dry when we assemble things. Now you can use a degreaser or even alcohol to clean off grungy collets. And now we're using a brand new collet, so it has that thick, waxy rust preventative on it that we're going to have to get rid of. We'll want to clean off our holder and our collet nuts as well. Now I'll use a lint-free cloth with some rust preventative on it. I use Castrol Rustillo, that's what we have here at the factory. And I will go ahead and wipe down the threads. Now this is why I do that, and I don't do it all the time. Earlier we showed you this high-performance collet. This is a 5-micron collet, a good collet from Parleg. And it's got a high polish on the outside, while they didn't spend quite as much time on the ID polishing it. And there's a reason for that, because they want the outside to slip nicely against the inside of the holder, low friction, but they want the ID of the collet to have more friction, a rougher surface to hold on to our tool. This is why you don't want to soak an entire collet with oil and leave them that way. That's great when they're on the shelf. If the ID of this collet is just soaking with oil, it's going to have less hold on your tool, and your tool will be more likely to pull out. But when they go into our holder, we want them typically clean and dry. If you find a damaged collet or a collet nut or holder, get rid of it. You don't want that thing in your shop. It'll work its way from tool holder to tool holder, ruining everything you've got. So if you see a bad part, don't set it aside for later. Get it out of your shop. Most collets have an eccentric extractor ring, a lip that helps pull out the ER collet during disassembly. This can make them hard to put together or take apart if you don't know the secret. Most collet nuts have a mark on the bottom of the nuts or on the rotating friction ring that shows us our pivot points for loading the collets. Tilt the collet, load it at an angle, tucking it behind that extractor lip, then tilt it up. If it is too difficult, we may be tilting it the wrong way. Rotate the nut in your hand until the collet just snaps in. But we never, ever set the collet onto the holder and screw the nut on. We can break our nut and we can damage the collet. Ideally, when we load up a tool, we're going to be holding onto it by the entire length of the collet, or at least 2/3 of that collet. Now, you can use a tool with the weld and shank, but you may lose some clamping force. But never let the gap in the weld and shank tool hang over the edge of the face of the collet. And if running a drill, never clamp on the flutes. One last thing about loading up tools in an ER collet. Right here in the center is a backup screw. If you drive your tool all the way up against the back of the holder and then tighten your collet, it could force the tool to wobble, causing us run out. You don't want that. So normally we don't want the tool set all the way up against the backup screw as we tighten that nut. We want to leave some room, and then we can come back later and gently move that backup screw up against the back of the tool if we really need to. This has an Allen wrench in the front, and we can reach it with a flat blade screwdriver from the back through the TSC pull stud. Now I said TSC. Now take a look at this guy. Look how small the hole is through this particular backup screw. If you're running a TSC drill that needs lots of volume of through spindle coolant, you're better off removing this backup screw altogether. All it's doing is choking your coolant flow. When I load up tools that other people have assembled, I always look at the gap, the slots in the collets. If you don't see any visible gaps in the collet, then the last setup person might have chosen a collet that's too large for the tool. If the gaps are really big, they might have chosen a collet that's too small for the tool. Either way, take everything apart, make sure you're using the right size collet, clean everything, and put it back together. Now, if you see a collet where all the gaps are uneven, something's gone really bad, okay? They didn't clean or assemble the tool properly, or they over-torqued this nut, causing the collet to twist badly. In that case, take everything apart and also check to make sure that your nut is not cracked. That's why it is always a good idea to use a torque wrench to tighten down those collet nuts. Even here in our own machine shop, we're using torque wrenches with adapters to tighten all of our collet nuts. Doesn't matter what style. Now, we mentioned earlier that low friction nuts take less torque to tighten than a standard flush nut, and mini nuts take even less torque than that. So here's my list of some generic torque values that you can use with most holders. But if you use these values, you might be leaving something on the table. They might not be perfect for your tools. In the description of the YouTube version of this video, we'll give some links to different tooling manufacturers with their actual torque specs. There's some great websites out there for each manufacturer. Check them out. The torque specs from the manufacturers are based on the largest tool that'll fit in that collet. Now, as we use smaller and smaller tools, we'll want to use less and less torque. Essentially, you'll want to take it easy on tools that are smaller than about 4 millimeters or 3/16 of an inch. Now, if you're tightening up those tools by hand, you'll want to use one of these slotted wrenches. We've got spanner wrenches as well. I prefer the slotted wrenches. They give you a better hold on the collet nuts. They come in all different sizes. We also have these non-slip versions. These are really popular, an AX wrench for our live tooling. And we've got our castle wrenches, our ERM wrenches, which we use on mini nuts. We don't need much torque on these guys at all. Remember those polished collets that we showed you earlier? They were great because they reduced friction between the collet and the nut and the holder. If I've got a corroded collet, then I'm not going to throw it away typically, right? Because I'm cheap. I'll take a Scotch-Brite pad or a light abrasive pad and some rust preventative, and I'll clean off that surface rust. But by doing so, I'm making the surface of my collet more porous, which means it's just more likely to rust in the future. Not only that, but with that more porous surface, we're going to add friction into our ER system, which is bad for runout. So I keep them, I use them, but I don't use them on tight tolerance tools. Which brings us back to rust preventative, right? You want to come up to the collets in your rack. We're using a rack so the collets don't damage each other, but we want to come up to these collets every now and then and wipe them down with a rust preventative. This is kind of the takeaway of this video. Make sure you keep your unused collets well oiled so they don't get damaged with corrosion. Make sure that you're using the right collet nut for the job, whether you're using a low friction nut, flush nut, coolant nut, and make sure those things are clean and dry when you assemble them, right? Or maybe a light sweeping of oil on the outside of your collet or on the threads, and torque those collet nuts as necessary. That's it. We'll be looking forward to seeing you next time in the next Haas Tip of the Day.